Hello students, how are you all? I hope all of you are doing amazing. So welcome all of you at AriserTalent, and I'm your physics teacher Krina welcomes you all. So let's move to the quote of the day. All of us do not have equal talents but equal opportunities to develop that talent. It means we do not have equal talent at all. Some have a high talent and some have a low talent, but equal opportunities are provided to us in every field, and to compete with that talent, AriserTalent is always with you, and it provided a wide variety of courses, whether it is from CBSE, NTSE, JEE and NEET level exam. Along with it, you will get a doubt session also where you can post your doubts, and we are available to you every time to solve your problems. So what you have to do, you have to just subscribe our channel, like our videos, and free video lectures are also available to you. So just have a look at these videos. So let's move to our chapter, and we are dealing with the magnetic effect of electric current, and until now we have a discussion about AC and DC generators. So in our second chapter of physics, that is about magnetic effect of electric current. Today we are going to discuss a very important topic and very interesting topic, that is about the electric motor. So you have heard about the term motor. We have seen uses of motor in a wide variety of the electronic appliances and electrical devices in our homes. Whether it may be the refrigerator, it may be washing machine, it may be computer, or it may be MP3 player. All devices are actually working because they have a motor installed on them. So today we are going to start our discussion with electric motor. So in our previous lecture, we have a discussion about electric generator. So electric generator is doing what? It converts mechanical energy into electrical energy. So just opposite function is performed by the electric motor. What it will do? It will just convert electrical energy into mechanical one. It will convert electrical energy into mechanical energy. So this device is just opposite to that of the previous device we had discussed, that is generator. So don't get confused between them. Generator just converts the mechanical energy into the electrical one, and the motor is going to convert the electrical energy into the mechanical work. Now, where we find the uses of motor in our day-to-day life? If I am talking about washing machine, washing machine will have a motor installed in them. If I am going to talk about the computer, it will also consist of motor. If I am going to talk about mixer grinder, it also consists of motor installed in them. And if I am talking about MP3 player, these all devices will going to work on the motor. Without motor, their functioning will not be possible. So all of these devices will have a motor installed in them. Now, the motor we are going to have a discussion about is actually a DC motor. This will be our DC motor. And DC means direct current. So this motor will be work on the direct current. So today we are going to discuss about the DC motor we have in our syllabus. Now one thing we have seen that the motor is actually converting the electrical energy into the mechanical energy. But how it works, we have to see the construction and working part of that electric motor. So similar to the generator, it also consists of a two strong magnets in which the rectangular coil is going to be rotated. So let's move to the construction of electric motor. So we have construction part. In that construction part, firstly we have the two strong electromagnets. Now, this is how the actual DC motor looks like. It consists of two strong electromagnets which is having a north and south pole, and a rectangular coil ABCD is placed between the two poles of a magnet. Now, this ABCD is actually connected to an axle. This part is our axle. And you can see that these two parts are connected to the two split rings. These are two split rings we have. This part is our split rings. And these two are again connected with that part, and these are nothing but our carbon brushes that we have discussed in the generator part. These are carbon brushes. Now, this whole system is connected to a battery and key for supplying the source of electric current through it. So this part will be our battery, and this part is our key. Now, this ABCD is actually our rectangular coil. And these are two magnets we have. And I can name this as P and Q, and these brushes are termed as X and Y. And this is our axle. So this is how the electric motor actually looks like, and these are actually the components of the electric motor. So just copy this diagram from here so we can proceed to our next part. So this is the components we are using in the electric motor, and we will deal with all these components one by one now. So firstly, what we have taken the two magnets here. These are actually the strong electromagnets we are taking in the devices, and a rectangular coil ABCD is placed between these two electromagnets. So what we have taken here, firstly let's see what are the components of electric motor here. So in the construction of DC motor, firstly what we have taken? We have taken two strong electromagnets. So firstly, two electromagnets having north and south pole. Now, what is the second thing we have taken? The second thing is the rectangular coil ABCD having a large number of the turns of the copper wire insulated on it, and it is again connected. The ends of this will be connected to the split rings we have. These ends will be going to connect to P and Q only. So second thing we have taken here will be, we have a rectangular coil ABCD, and this ABCD is actually made up of insulated copper wire. It is made up of the insulated copper wire, and ends of this rectangular ABCD is connected to the ends here, that is known as the P and Q, and P and Q are our half rings, which is known as the split rings. P and Q are the half rings. So next two components are P and Q. This P and Q are known as split rings, and you can see that the split rings have their inner part insulated with some material. It means in the inner part of the split rings we have to provide the insulation here. So P and Q are insulated from inside. So this is the P and Q, which are our split rings. Now you can see that these split rings are again connected to that part, and this part is nothing but our carbon brushes. These are actually our carbon brushes. And these carbon brushes are denoted by the letters X and Y. So we have another component here, that is X and Y, and X and Y are carbon brushes. Now, this part that is described here in a cylindrical form, you have to draw this part in a horizontal manner, as I have drawn in the vertical manner, because it is not possible to draw this in the 3D. So this part is known as the axle, which is going to rotate along with this rectangular coil. So this part is our axle, and these carbon brushes are next attached to a battery and a key from which the source of electric current has to be provided. So what are the other components here? The other components here are source of battery and key. So this is the whole picture about the electric motor and the components and the construction part we have used here. Now, split rings are sometimes also known as commutator. So another term we came to know across is about the commutator. These are also known as commutator because it is going to reverse the direction of the current in each cycle of the rotation of this coil. Now, if you want to find out the direction of the current in the system, we have to apply the Fleming's left hand rule, and this rectangular coil ABCD is placed perpendicular to the magnetic field in this system. So I can say that this coil is placed perpendicular to magnetic field. This coil has been placed in perpendicular to that of the magnetic field. So this is the whole thing about the construction part of the electric motor. So if any question arises in your exam related to that part, so firstly you have to write the definition of that particular device, then you have to write the principle on which it is working on. Next we have to discuss about the construction, working and the uses, and this will be your complete theory question which consists of 4 to 5 mark question in your exam. Now, this is the construction part we have seen. Now, let's move to the working part of the electric motor, that how actually the electric motor works. But firstly, just copy this part from here. So now, let's move to the working part. So, our next topic is about working of motor. Now, what will happen here? The current through the battery will going to enter through the carbon brush X in this system, and you can see that this will be the direction of current here. When the current start flowing from the positive terminal of a battery through carbon brush X, it is going to be in arm AB, and you can see that the direction of the current will be from A to B and C to D, and we can see that these two directions are just opposite to each other. Now, if current is entering from this source through X and it is again coming to the battery through the system Y, so I can draw the symbol like this. So we can see that in step number 1, what is happening? In step number 1, the current from battery through X is passed to a rectangular coil ABCD. And from where does it living? It is just living from the carbon brush Y, and it is again coming to a battery that is placed here. Now, the direction of the current will be from A to B and C to D, and you can see that this direction is just opposite to each other, and it is in accordance with the Fleming's left hand rule. So, which rule we have applied here? We have to use the Fleming's left hand rule. Now, in second case, the current will be from A to B and C to D. This is the direction of the current in this picture, and you can see that these two directions are just opposite to each other. These are the opposite direction we have. So, the force is pushing AB into the upward direction and CD is pushed in the downward direction, as you can see in this picture. Now, if I am taking the direction as an anti-clockwise in the step number 2, when you turn this coil, you can see that the direction will going to be reversed here. AB will be pushed downwards and CD will be going to push in the upward direction. So, this will be happen in the second case we have, and you can see that in both the cases and in each turn it reverses its direction, and this axle is going to rotate in each and every turn, and this is how the motor actually works. So, this is the direction of current that will be from A to B and C to B, and it is according to the Fleming's left hand rule. So, it is used to determine the direction of the force here. So, what will happen in the first case? If we want to find out the direction of the force, we can see that in the first half cycle, AB will be pushed downwards. So, we can write here we have the 2 half cycles here. So what will happen in the first half cycle? This AB will be going to be pushed downwards. So in the first half cycle, AB will be pushed downwards. And CD will be pushed upwards. So this force is making to push it in the upward and the downward direction, and you can say that the direction of the current will be in the anti-clockwise manner. So it will be, the current will going to be flow in the anti-clockwise manner in the circuit. So I can say that the direction of current will be anti-clockwise. Now, in first case, what will actually happen here? These brushes and split rings are making contact with each other. So Q will be connected to X and P will be connected to Y. So in this system, what will happen? X will be connected to Q and P will be connected to Y. This will make a contact. It means there is a contact between the split ring and the brushes. Now what will happen in the next cycle? Just opposite case will going to be occur in the next cycle. So what will happen here? In second case, AB will be pushed upwards and CD will be pushed downwards. So the direction of the current will be DABC. It means the direction of the current will be clockwise in this system. So we can say that current is going to be flow in the direction that is DABC. DABC. So in the first case, we have seen that AB is pushed downwards and CD is pushed upwards. In second case, the just opposite picture occurs, that AB will be pushed upwards and CD will be pushed downwards, and you can see that the direction of the current will be just opposite in both the cases, and it can be found out only by using the Fleming's left hand rule. Now, the brushes have an opposite contact with the split rings, and I have told you earlier that split rings are also known as commutator. And what is the purpose of commutator? Commutator is just used to reverse the direction of the current in the circuit. So that's why we are using this system. Now, when you apply or when you are substituting the current in the system, you can see that this coil and this axle, these are interconnected to each other. They are going to rotate in the system, and if they are going to rotate, they are going to develop the current in the system, because as soon as the current is applied, these two will going to rotate between these two strong electromagnets. What is going to be rotated? This rectangular coil ABCD and this axle, because they are making the contact with each other. So they both are mounted together and they are going to rotate in the system, and in the first case, we will get the direction of the current will be in the anti-clockwise manner, and in the second case, you can see that we are getting the current in the clockwise system. So the direction of the current will be from DABC in this system. Now, this is how the electric motor actually works. But what will happen nowadays, the electric motors are not using the permanent magnets. They are actually using the electromagnets we have. So I guess that the working of the motor has been cleared to you. So there are few, we can say that there are few points about the motor. So we have to discuss these points also. So if I am talking about commercial motors, the commercial motors nowadays are using electromagnets. They are using electromagnets. Secondly, the motors we are using have a soft iron core. They are using soft iron core, and soft iron core Along with the soft iron core of the armature is used to enhance the working of the motor. If we are using the soft iron core, it means that we can enhance the speed of the motor also. And thirdly, they are using a large number of turns of the copper wire. So it is also using a large number of turns of the copper wire. So this is the whole thing about the commercial motors we have. So this is all about our topic electric motor, and we have just completed this topic. I hope this topic has been clear to you. So this lecture is over here. Thank you so much and have a nice day.